G'day everybody, where's Wally here? Well, AVO, he dropped a video the other day and man, I love his stuff. Talk about popping up softballs for me to smash. So let's have a look and smash some AVO on toast. So AVO is looking at his favourite camera on Mount Wellington in Tasmania. Now this is a cool camera. It's an Axis P3818 PVE camera. It has 4 sensors that auto-stitch together to form a 180 degree by 90 degree view. Now this camera is facing east and looking over Hobart, and he was looking at the full moon on the 4th of June, which happened around 1:30 PM Hobart time. Now AVO, he saw that there was a rare clear sky, and that afforded him some good views of the whole 24 hours. Firstly, the moon just set when the moon rose at around 7:30 AM, and then later the sun was just setting and the moon rose a little bit later at 4:30 PM. Now AVO decided to have a look at the angles, but what he did was truly shoot himself in the foot style of debunking. Now he used an old site that did a fair job of calculating the GPs of the sun and the moon at, well, that's the wrong time there, AVO. It's a few hours late. I bet he couldn't figure out how to make that old site do the time that he wanted. Well, it doesn't matter, but it is using a Mercator projection, it seems, so distortions much? Then it seems he just draws lines on that. Then AVO does something that is actually pretty cool. He notes that the angle of the moon's shadow moves towards the east horizon and points to the rising sun, even though the sun is well north. Then 12 hours later or so, he notes that the shadow cast by the setting sun points to where the moon is about to rise. Well, that is so cool. But it's not at all unexpected. Remember that just one lunar month prior, we had a penumbral eclipse. That is when the sun, earth and moon are all in a line. So little surprise that just one lunar month later, they are once again close to alignment. Now I plotted all 4 angles from sun calc and moon calc on one map, and they all line up with each other as expected when the sun and the moon are antipodal at the time of the full moon. Now if you doubt me, AVO, just get those 2 locations for the GPs of the sun and the moon and tell me, are they roughly on opposite sides of the globe? You still have a globe at home, don't you? All in all, this is a nice self-debunk. Thanks for showing facts that don't line up on a flat map but work perfectly well on a globe. Still not convinced? Just have a look at the nautical almanac. The full moon is that hour where the GHAs are 180 degrees apart. And look at just how close those latitudes are too. Now that is pretty close to antipodal. Still not convinced? So to double check, let's have a look at the nautical almanac for the 5th of May when there was that penumbral eclipse. And yes, they are exactly 180 degrees apart, but I did think the declination values would be closer. They're about half a degree apart. But wait, isn't the angular size of the sun and the moon around half a degree? Aha! Oh, and wait a second time. This is a penumbral eclipse, which is more like a near miss anyway. Okay, so that is rather very cool. And I can't let this little gem slide by. You guys know exactly what I'm seeing here, don't you? Indeed, the belts of Venus, and you can perfectly see how the mountain shadow just keeps going up the sky. Oh, and one more thing, AVO. When a website mentions the code base that they're using, this guy's using PyEnv, which is Python code for doing the Amphiris data, you might want to be a little bit careful because sometimes they use things like constants that are radiuses. I mean, it is absolutely hilarious that the website that you use to calculate the GPs is actually using globe maths. Sorry about that, AVO. You're smashed. But don't stop trying, mate. I love your stuff. Oh yes, then there is the Himawari 8. Sorry, the Himawari 9. It showed what looked like clouds, and the mountaintop camera should be able to see all that way out to sea, and it could not see that cloud, or whatever the Himawari 8 was showing. Well, AVO, I guess you haven't figured out what's going on here, have you? It's a pity that the Himawari website does not seem to give out the individual scan data anymore for each of the 16 filters. They used to make them all available, but now the product delivery system seems to have changed somewhat. But looking at this image that AVO has used, we can see that there are 2 different types of cloud colouring. I wonder if there is a bit of IR layering being displayed here. Now, what we do know is that the Advanced Himawari Imager is not just a P900 stuck under the dome. We also know that there are 16 bands that the Advanced Himawari Imager used to scan the disk of the globe every 10 minutes. So to get this imagery at night, they are not just relying on the 3 visible bands, because if they did that, it would be black. So given that they're using the other light bands, they may well just be able to see things from the satellite that the web camera on the mountain is not able to see. Well, I was almost done making this video and I saw here one other claim here, that the Himawari just can't see city lights at night. Well, let's not worry about the fact that the ISS does quite a really good job of this. So I started thinking about, well, this is a weather satellite. It's not a looking to see whether I left the garage light on satellite. And then it occurred to me that most of the city lights are coming from street lighting, which are pretty much universally these days sodium vapor lamps, and the emission spectra of sodium vapor puts it in the yellow region, which the Himawari Advanced Imager just can't see. Oh my goodness, these guys are terrible at research. I do like to smash you, AVO, and when I learn something in the process, then I just want to share it with you guys. Thanks a lot.